Alright. Okay, today the first thing we want to go over is kinetic energy and potential energy.
Man, why it's so hot in here?
Because something screwed up downtown. It's been hot. We already called it. Okay? Kinetic energy, they may sometimes also write as K E. Ke. Okay? And potential energy they'll write as PE on the test. And that does not mean physical education as in your PE class. That means PE as in physical or potential energy. Okay? Now, the way I describe these is kinetic energy is moving. Simple as that, moving. So if something is moving, does it have kinetic energy? Yes. If something's moving, does it have kinetic energy?
Yes.
Yes, okay? So if it's not moving, it has potential energy. Okay? Just like if I look at a student, let's say I look at Alex, and I say, Alex, you have potential. Have you done anything yet?
No.
No, but can you?
Yeah.
Yeah, you have potential to do something, okay? Once you start doing it, then I say, okay, you turn that into kinetic energy. So if you can think of a hill with a ball on top of the hill. Does this ball sitting on top of a hill have kinetic or potential energy?
Potential.
Potential energy, right? Because what if I just give it a little touch? What's going to happen? It's going to start rolling down the hill. Okay? So at the top of the hill it has potential. Once it starts rolling, it has what?
Kinetic energy.
Good, equals kinetic energy. Okay? Now, on the test, you'll see it this way. You'll say, okay, well it started out as potential energy and it went to kinetic energy. And then what happens to the ball once it hits the bottom of the hill? What happens to the ball? It goes back to potential, right? So if it is rolling, it starts out moving, kinetic energy, and it goes to potential. That means it was moving and it stopped. If it's potential energy, it was stopped and it started moving. Okay, so here it has potential energy, starts rolling down the hill, which is kinetic energy, and then what happens when it hits the bottom? Potential energy. So then it stopped again. So what's kinetic energy?
It moves.
Moving. What's potential energy?
But doesn't move.
Doesn't move. Okay? That's what you need to memorize for the test. Don't worry about getting into other details. There are more details to it, but that's all you need to know for this test. So what's kinetic energy?
It moves.
Moving. What's potential energy?
It doesn't move.
What's kinetic energy, D-Tom? What's potential energy? Not moving. Alright, good. Now, the next word we need is an atom. Okay, it's the smallest unit that maintains properties. Okay? So what are desks made of?
Atom.
Atoms. What are chairs made of? Atoms. Your pencil is made of atoms. Okay? All your things that you use on a daily basis are made of atoms. Now don't get that confused with what are living things made out of. What are living things made out of? Not atoms, but cells. Okay? So atoms are living or not living? Non-living. And what's our word for non-living? Abiotic. What means non-living? Abiotic. Okay, so are atoms biotic or abiotic? Abiotic. What are cells? Biotic. Because biotic means living. Abiotic means non-living. So atoms are, cells are biotic. Good. Alright. So then the three parts of an atom are the protons, neutrons, and electrons. Protons, neutrons, and electrons. You remember this as what are protons? What charge? Positive protons. So positive charge. What are neutrons? Neutral or no charge. And so electrons must be negative. Okay? So easy way to remember it. Positive protons, neutral neutrons, negative electrons. Okay? These two words, protons and neutrons, sound like their definitions. Positive protons, neutral neutrons. And then what are electrons?
Negative.
Negative. Okay? Now, on your periodic table, I want you to find carbon. Find carbon. Okay, and it'll look like that, right? On your periodic table. This is what they'll give you on the test, is a periodic table. What does this 6 represent? It represents the
Atomic number.
atomic number. Okay, and your atomic number equals what? No, your atomic number doesn't equal your atomic mass. Your atomic number equals the number of protons. Good. Atomic number equals
Proton.
number of protons. Okay? And then this one is the atomic what?
Mass.
Good. And the atomic mass equals what?
Neutron.
Protons plus.
Neutron.
Good. Protons plus neutrons. Okay? So the atomic number equals the number of what? Protons. The atomic mass equals, what's the atomic mass? Protons plus neutrons. Okay? So how many protons does carbon have? Carbon, good, has 6 protons. Could carbon ever have 7 protons? No, because what if it has 7 protons?
Would be nitrogen.
It would be nitrogen, right? Y'all see that on your periodic table. If it has 7 protons, it's got to be
Nitrogen.
nitrogen. What if it has 5 protons?
Boron.
It's boron, right? So can you change the number of protons ever?
Nope.
So anytime they ask you about carbon, how many protons does it have to have?
6.
6. Can that change?
No.
No, cannot. Okay. Next, an atom wants to remain neutral. So to remain neutral, if it has 6 positive protons, it has to have how many electrons to balance out 6 positives?
6 negatives.
Good, it has to have 6 negatives. In a normal atom, if it has 6 protons, it has to have how many electrons?
The same.
The same number, right? So it has to have 6. If it's oxygen and it has 8 protons, how many electrons will it have?
8.
8. But we're working with carbon and it has how many protons?
6.
6.
So it's got to have
Negative 6.
-6 to balance it out. Now, we know that the atomic mass of carbon equals what? And just go ahead and round it.
12.
12. Good. So our formula is atomic mass, which I'm going to write as AN, equals protons plus neutrons. Okay? What's our atomic mass? 12. How many protons does carbon have?
6.
6. Can we figure out the neutrons?
Yeah.
Yeah, right? What do we do?
12 times 6.
Good. Subtract 6 on both sides.
Oh.
Okay? Because we're adding it, subtract it. So 12 minus 6 is 6. 6 minus 6 is 0 plus n. So 6 equals n. So how many neutrons do we have?
6.
6. Do you see how we figured that out? Our atomic mass minus our atomic number equals our number of neutrons. So neutrons equal atomic mass minus atomic number. Can you ever change the number of protons?
No.
No. In a normal atom, the number of protons must equal the number of electrons, okay? So on the test, if they say, okay, you have a carbon atom, we want to know how many protons, neutrons, and electrons it has. First off, you look at the protons. If the number's not 6, do you want to choose it? No. If on carbon, if the number is not 6, do you ever choose it? No, you never choose it. So you can mark out whichever one has 7, whichever one has 5. Okay? And then you look at the electrons. Now, the next two words you need to know is called an isotope and an ion. An isotope, or well, let's do ion first. An ion changes number of electrons. Can we change the number of electrons without changing the atom? Yes. Okay, so an ion changes the number of what? Electrons. An isotope changes number of neutrons. So an ion changes what?
Number of electrons.
Electrons. An isotope changes the neutrons. And both of those are legal. Okay, so we can do that without changing the atom. Because as long as the atom has the correct number of protons, it's still that atom. Alright? So as long as carbon has how many protons? 6. It's still carbon. Okay. So what they might do, did everyone get this? Got it? Okay. So what they might do is they might say, okay, I want to know how many protons, electrons, and neutrons are in carbon with a charge of -2. Carbon with a charge of -2. How many protons does it have to have? 6. Okay? So if one of your answer choices doesn't have 6, don't choose it. Now, it has a -2 charge, so what happened?
4.
Now, how many electrons do you have if it has a total of -2 charge? How many protons does it have? 6, so it has 6 positives, right? Okay, so first, you have to have enough negatives to balance that out, right? So in this case, we're going to have 1, 2, 3, 4, 5, 6, right? So these balance each other out, right? Everyone agree? Yes? Now, if we want to have an extra -2, we have to what?
Add 2 more.
Add 2 negatives. So now how many total electrons do we have?
8.
8. 8 electrons. And then how many neutrons? Did we change the number of neutrons?
6.
So how do we find the number of neutrons? What do we do?
Subtract.
Take the atomic 9.
What do you do, Bridget?
Subtract.
What 2 numbers?
8 and 6.
8 and 6? No. What's the atomic mass? Protons plus neutrons. So what's our atomic mass of carbon? 12. And what's our number of protons? 6. So 12 equals 6 plus n. So what do we have to do? What do you do?
Subtract.
Subtract what?
12 and 6.
Good. So 12 minus 6. So how many neutrons do we have? 6. Okay? Now, the other way you could go is, let's say one time it has carbon plus 2. So now it has a positive 2 charge. Okay, how many protons do we have? 6, because we can't change that. So we have 6 protons. Now, this time, we have how many electrons? Because it's going to have a positive 2 charge. So it's going to have how many positives left over? 2. So we can only balance out 4 of them. So these balance, 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 and what are we left with?
2.
We're left with 2 positives. So how many electrons do we have here? 4. Okay? So to get a negative charge, you have to add electrons. To get a positive charge, what do you do with electrons? Subtract them. Because because electrons are negative, it's kind of the opposite of what you would think, right? So to get a positive charge, what do we have to do with some of the electrons?
Subtract.
Get rid of them. Okay? To get a negative, we had to add them. Now, did the number of neutrons change?
Nope.
No. So it's still 6. Okay, so whatever answer you chose on the test would have to have 6 protons, 4 electrons, still 6 neutrons. Okay? Now, the other thing they can change, what's it called if you change the electrons? It's called an, you change, good, ion. Ion means you changed what? Electrons. What is it if you change the protons? Or sorry, change the neutrons. What is it if you change the neutrons? Isotope. So now we're going to make an isotope of carbon. Okay? And we want to make one with a mass number of 14. We want to make one with a mass number of 14. How many protons does it have to have? 6. How many, if it's still just neutral, how many electrons? 6. Okay, so now we're changing the neutrons. So what's our new atomic mass? 14. So atomic mass equals 14. What's our number of protons?
6.
Good. Protons equals 6. So what do we do?
Subtract.
Good. 14 minus 6 equals
8.
8. So how many neutrons do we have? 8. So does that add up to 14? 8 plus 16 equals 14. Right? Does everybody see how we did that? Yes? No? Alex, you got it? Bridget? You see how we did it? No? Really? Really? You don't see? Okay, so what's our new atomic mass? 14, right? And we know that our equation is atomic mass equals protons plus neutrons, right? Right? Okay, what's our new atomic mass? 14 equals, what's our number of protons? 6 plus our neutrons. We don't know that yet, right? So, well, how do we get the neutrons by itself? Subtract 6. So subtract 6 from both sides. You get 0 plus n equals what? 8. So our neutrons, get rid of that 0, our neutrons equals 8. So this is an isotope because we changed the neutrons. Because normally we said carbon has how many neutrons? 6, and we changed it to 8, so it became carbon 14. Everyone got it? Easy enough. All right. Now the next 2 definitions I want you to know, which we're going to use them more later this week. I just want you to know what they are and kind of get them memorized so that tomorrow or Wednesday when we talk about it, you guys won't have any problems. So, 2 words I want you to know are ionic bond and covalent bond. Okay? A covalent bond is between 2 atoms when 2 atoms share electrons. When 2 atoms share electrons. An ionic bond is a bond when 1 atom takes electrons, other atom receives. Not before E. electrons. So an ionic bond is when one atom takes electrons and the other atom receives them. What do they do in a covalent? They share. In ionic, one says, here, you can take it, I don't want it. The other says, good, I wanted one, and I'm not going to share it. So covalent, what do they do?
Share.
In ionic, do they share?
No.
No. In covalent, what do they do, Alex? Share. So when you think of a covalent bond, you think of
Sharing.
sharing. Okay? Alright, so that's all the new stuff.